All right, today we're tackling one of the biggest, most mind-bending ideas in all of science, dark energy. You know, the stuff that's supposed to make up most of our universe. But what if it's not actually real? We're going to dive into a pretty compelling critique that asks if this huge pillar of cosmology is, well, just a phantom. So let's just jump right into the deep end, shall we? What if the biggest discovery in modern cosmology just plain doesn't exist? I mean, that's a massive claim. And if it's true, it could force us to rethink, well, pretty much everything we thought we knew about the universe. So, here's how we're going to break this whole argument down, step by step. First, we'll get a handle on the current dark energy paradigm. Then, we'll look at why some say the theory is constantly shifting. After that, we'll explore something called the interpretation gap, consider some other possible reasons for cosmic redshift, and finally, we'll ask the big question, is dark energy just unnecessary? Okay, so first up, the dark energy paradigm. Before we can really start poking holes in this pillar of modern science, we've got to understand what it is we're up against. So, what even is dark energy? Well, in the standard model, it's this mysterious, kind of weird, repulsive force that's pushing everything in the universe apart, making its expansion speed up. And listen, we're not talking about some minor detail here. This stuff is thought to be the single biggest ingredient in the entire cosmos. It's the accepted story for why the universe looks the way it does. But here's where the critique we're exploring today comes in, and it starts with a pretty powerful warning. It argues that science can get stuck when it's too committed to an established idea. In other words, just because everybody believes something doesn't automatically make it true. Sometimes we end up chasing ghosts.
And that leads us right into our second point, the idea that the theory itself is constantly shifting. The argument here is that dark energy isn't some solid, stable concept. It's more like trying to hit a moving target.
And this is where it gets really interesting. See, the whole concept of dark energy has been, well, kind of fickle. At first, the idea was that it was this simple, constant vacuum energy. But now, the story is changing. Some theories suggest its influence is actually fading, that it's getting less. The source makes a great point. If the theorists themselves are saying tomorrow they will think something else, how can you build a solid physical reality on such a shaky foundation? This instability is what leads to this really crucial idea that dark energy might just be a mathematical ghost. Think about it. The argument is that it isn't a real thing out there in the universe, but more like a fudge factor, a residual error we invented to make our equations balance out. And the stakes here are just incredibly high. I mean, if this critique is right, are we really wasting decades of observational time on a moving target that does not exist? That's a heavy question, and it really gets to the heart of why it's so important to challenge these big ideas. Which, of course, brings us to our third section, the interpretation gap. The core question here is, are we just misreading the evidence? Is the data we've collected actually trying to tell us a completely different story than the one we've been telling ourselves? So how do you end up with a scientific phantom? Well, according to this argument, it's a three-step process. First, you collect amazing, beautiful, high-resolution data. But then, and this is the key part, you filter that data through a flawed lens, a flawed framework. And what's the result? You get a procedural misattribution, a fancy term for getting the wrong answer because your method was off. And then we slap a cool, mysterious name on it, dark energy. Now, let's be super clear here. The argument isn't that our telescopes are wrong or that the data is bad. The data is incredible. The claim is that dark energy was never a physical discovery in the first place, but a conceptual error. It's a ghost that was born in our math, not a force that exists out in the cosmos. Okay, so if it's not dark energy, then what the heck is going on? This takes us to section 4, other reasons for redshift. What if there are some key variables we've just been ignoring this whole time? Right. I mean, you can't just throw out a huge idea like dark energy without having some kind of alternative. What else could possibly explain the measurements that led us to this idea in the first place? Well, this critique says our models are just too simple and that we're ignoring several things that affect redshift. For instance, there's this idea of the variable size of the fermion carrier ball, which I know is a mouthful, but it basically means the fundamental particles carrying forces might change size over billions of years, which would totally change how light from distant objects looks to us. It also suggests we haven't fully accounted for the regular old movement of galaxies, or even the wild possibility that the speed of light isn't a perfect constant. The main point is, there might be other real physical processes at play that we're currently leaving out of our equations. And here's the kicker. The source argues that once you start to factor in these other physical processes, the evidence for an accelerating expansion starts to look, well, a lot more shaky. And if the acceleration isn't really happening, then the need for dark energy, this mysterious force driving it, it just vanishes. It becomes, as they put it, premature speculation. So where does all this leave us? In our final section, we ask the big one. Is dark energy just a superfluous concept? Are we ready to start thinking about what a post-dark energy cosmology might look like?
Let's just boil this entire critique down to its three core pillars so it's crystal clear. First, the theory is unstable. It's a moving target. Second, we're making an interpretive error. We're misreading good data through a flawed framework. And third, we're omitting variables. We're ignoring other real factors that could explain what we're seeing. And in its final verdict, the source really doesn't pull any punches. It states flat out that dark energy is a superfluous concept that will eventually be discarded. That is a seriously bold prediction, basically saying this entire paradigm is just a temporary stepping stone on the path to a deeper understanding. And so we're left with this final, really provocative question. Is it time for cosmology to move past this placeholder? To look for answers grounded in a more complete, more rigorous physics? That's the challenge this critique leaves us with, and a powerful reminder to always keep questioning. Thanks for digging into this with me.